Yeah, so we were looking at some points to note about recursion. The first one is something we've already seen. Second one, use return statements inside the function with caution. So what do I mean by this? So here our function is returning a value. It's not printing, right? So how does it make a difference is, if this is where the stack is important. So if you look at this function, when you reach the base case, this is our factorial function. So when you reach the base case, it is simply printing and it's not doing anything more. So how the stack works is 5, 4, 3, 2, 1. When you reach 1, it prints and then it just gets deleted from the stack, and then the subsequent elements also get deleted. But when it's a function which is supposed to return something like return a or return flag, how the stack works is, it returns, if fib of 2 is supposed to return something, it will return it back to whoever called it. So if fib of 4 called fib of 2, it will return this value back here. So if I give a return statement in the base case and I don't give a corresponding statement in the recursive cases, let's say here I just give here let's say this return statement in the recursive case did not exist. It just had a print statement or a computational statement. What would happen is, this fib of 2 would return a value to fib of 4 and then it would get removed from the stack. But fib of 4, it would just hold the value with itself. It would not print it or do what it is supposed to. So if you are using a return statement over here, make sure this statement is coded appropriately. I am not saying if there is a return here, there has to be a return here also. It depends on the program, depends on what you have been asked to do. But whenever there is a return statement inside your recursive function, remember that the stack is going to return a value to whoever called it. So if you are telling someone I want something and they are saying I'll send it across, you should be there to receive it, right? Or you should at least have someone in that place and tell them I'm expecting a parcel or something like that. So that is what, if you are asking the base case to return something instead of just printing, make sure your recursive case is ready to handle what is being returned. So if there is no return statement, at least a is equal to p check of num or num comma factor minus 1. Like that you have to assign it somewhere. You cannot simply call p check of num comma factor minus 1 because it's returning something, it's not printing. That is what I am trying to say. So if using return functions, the function call must have a print statement in the main program. If not, it should just be function. So what do I mean? So finally, end of the day, base, recursive, everything over, this function is returning a value. So in my int main, when I am calling this function, I have to give print pcheck, because it will only return flag, I have to print that. Whereas if this factorial function, you see here, it is, where is the factorial function? It is already printing. So for this function int mainly, I can just give factorial of n. I don't need to say print factorial of n. So depending upon whether you have a print or a return inside your recursive function, a lot of things change. So handle them with care. That's what the second point says. Third one, recursion may not always be the most efficient. So I will digress a little bit here. So when I was in 7th standard and I was learning algebraic identities like a plus b the whole square, whole cubed and all that, I remember very clearly our teacher gave us one question. She asked us to solve using identities. I started and it was the first day we were learning identities. I started and I got confused at some point, and I thought I would rather write a plus b, a plus b, a plus b and multiply every term with every other term. That seems easier than this identities. And she said that is how it feels in the beginning, but the more you do, you get used to it, and when you're doing more complex sums, this comes very naturally to you, identities. And now when we're all doing anything that deals with algebra, when you see something like a plus b whole cube, you don't write a plus b thrice and multiply every term with every other term. You're so used to it, you automatically compute a cube plus b cube plus 3a square b plus 3ab square. At least most people do. So that is how recursion also works. When you're first learning recursion, you might not be able to crack the code for a lot of questions. You will feel like iteration is easier. But as you practice, generally as you get more comfortable with recursion, your brain naturally tends to a recursive code over an iterative code. You become very comfortable with that. So especially when you come to linked list and trees and all that, there are certain operations which if you had to perform using iteration, it would take, let's say, 15-20 lines of code. Recursion la panna, it is just 3 to 5 lines. So and there are some operations which cannot be performed iteratively at all. So when you start writing recursive code for all that, your instinct becomes to write a recursive code for any and every function. So that is when you need to remember that recursion may not always be the most efficient in terms of the number of lines of code or speed or memory consumption. So if you look at this program, for example, sum of n natural numbers, clearly the recursive approach is taking more lines of code than the iterative approach. And if you see the stack, again the recursive approach is taking up a lot of entries in the stack. So it is not quite an efficient. And again, in terms of speed of execution also, sometimes recursion may be efficient, sometimes it may not be. So generally when recursion is introduced to you, people say it is a more efficient way of writing code than iterative, which is true in a lot of cases. In a lot of cases, if iterative is going to take 15 lines of code, recursion will bring it down to 3 lines for you. But that is not always the case. So that is something you need to keep in mind. So there is no right or wrong code. If you think you are comfortable with recursion, you can go ahead and write something with recursion. If you feel iteration is more comfortable to you, you can go ahead with iteration, unless the question specifically asks for something. But yeah, just to tell you that recursion, just because sometimes the number of lines is condensed, it doesn't mean it is always efficient. And